In this demo, we will talk about a business process engine called Barcelona. Barcelona is a design and a runtime environment for modeling and executing artifact-centric business processes. Let's begin by understanding what an artifact is. A business artifact is made of two key components: an information model that describes the business relevant data that may be used during a process, as well as the lifecycle model that describes how information model is affected and how a process should progress by interacting with various role players and stakeholders. And lifecycle can be specified by different approaches. In Barcelona, two different lifecycle models are supported: a finite state machine based lifecycle, as well as a declarative lifecycle called GSM, or guard stage milestone. In the rest of this demo, we will focus specifically on GSM model. To understand artifacts with GSM lifecycle in details, let's explore an example called order to cash. The order to cash example describes a scenario in which a customer requests a generic product. An order for this product is created and submitted to an assembling company or seller, which is responsible for collecting needed components from a set of suppliers. Once all components are received by the assembler, the product is fabricated and then shipped back to the customer. In this example, we mainly focus on the process from a manufacturing aspect instead of the payment aspect. So for now, let's take a look at the Barcelona engine. The order-to-cash process in the Barcelona editor contains a single artifact, also known as the business entity, called customer order. Though there's only one artifact in this demo, in general, the engine can support multiple artifacts. The customer order artifact has an information model that contains all the simple type and complex type attributes that are needed during the process, as well as a lifecycle model. The lifecycle can be demonstrated through a newly implemented graphical user interface to visualize the lifecycle for convenient editing. What you've seen in this editor is the GSM lifecycle. A GSM lifecycle has three key components. One is the milestone, which are shown as circles, representing business relevant operational objectives. For example, an order is drafted or an order is submitted. The achieving of a milestone will close its corresponding stage, which is the second component, shown as the rounded corner boxes. A stage is a cluster of activities, which correspond to external service invocation that could be either manual or automated. A stage could be atomic, that just contain a single artifact, for example, the drafting stage and the submitting stage, or be hierarchically structured, like the processing stage that can contain nested stages. The third component is the guards, shown as diamonds, which are rule-based conditions to decide when to open up stages. For example, a guard init has condition self.submitted, which means that if the milestone submitted is achieved, the processing stage will open. For milestones, rules are also attached to determine when milestone achieved. For example, the milestone submitted has condition self.submitting on task success, which suggests that the achieving of the milestone depends on when the task inside the stage submitting completes. In other words, the completion of this task will first make the milestone submitted achieved, then accordingly close the submitting stage, and finally open stage processing. This chain effect or sequence of rule testing follows a theoretical property that helps the optimization of a GSM lifecycle. The new semantics has just recently been incorporated into the Barcelona engine. The conditions in Barcelona are written in Object Constraint Language, or OCL, which is newly supported by Barcelona. OCL is equivalent to the first order logic with quantification. With OCL incorporated, it helps the verification of a GSM schema. In addition, Barcelona also supports Java expression language for a wider choice. Now let's run the order to cache process. In the current engine, there are three running instances. Let's pick one of them. According to the status, in this process instance, the customer has drafted and submitted the order, and currently the seller is collecting the components from the suppliers. Let's click the onResearch event button to specify what components to be received. Let's say purchase order ID is 1, supplier ID is IBM, and none of the components has received. After that, the supplier can go ahead and deliver the components, let's say 1. And every time a component is delivered, the received value will increase by 1. After some of the components has been delivered, the assembler can go ahead to assemble the component. But it cannot finish the assembling because not all the components have been received. Notice that there are 3 components to be received and only 2 have been received. So let's go ahead and make another delivery. After that, the assembling company can go ahead and finish assembling. As a summary, the Barcelona engine incorporates a graphical editor, the OCL language that helps the verification, and the incremental or equivalent of fixed point semantics which contributes to optimization.